Hello, welcome back to FNM Labs. We have learned about the number system in our earlier classes. Starting from the natural numbers, we got introduced to whole numbers, integers, rational and irrational numbers, and real numbers. Having a taste of these number systems, we now get into a new way of expressing a collection of numbers or entities in mathematics, namely matrices. We will see what exactly is a matrix, and we'll have some basic introduction into the system of matrices in this chapter. This chapter is split into 3 video sessions and some additional sessions doing some exercises based on this topic. Believe me, this is going to be an interesting topic. So stay tuned. Have a great learning time. Let's talk maths. Suppose you want to record marks of students in 3 subjects in their first term examinations. For example, these are the marks of 4 students scored in 3 subjects. The above marks can be efficiently and effectively written in a tabular form. This tabular form is more expressive and convenient and also further processable. If we enclose these values inside a pair of brackets, we get a new mathematical way to represent a group of marks. In the same way, we can arrange the marks in second and third term examinations using this new representation. This new representation is called a matrix. Such representations collectively are called matrices. In this, each horizontal line is called a row and the vertical line is called a column. Thus, a matrix is a tabular arrangement of numbers or entities arranged into rows and columns. These numbers of a matrix are termed as elements or members of the matrix. Consider this matrix. Let A be its name. As a convention, we use uppercase English alphabets to name matrices. The elements of the matrix A are 2, -1, 3 in the first row and 0, 5, -3 in its second row. Obviously, this matrix has got 2 rows and 3 columns. Now, the order of the matrix A is written as 2 into 3. However, we read it as 2 by 3. In addition, we can see that there are 3 elements in each row and there are 2 such rows. So, the total number of elements is 2 into 3, which is 6. This means if the order of a matrix is 2 by 3, there are 2 into 3 equal to 6 elements in the matrix. Similarly, a matrix of the order 3 by 3 will contain 3 into 3, that is equal to 9 elements. So, the order of a matrix also indicates the number of elements in it. Thus, if the order of a matrix is m by n, then it has m into n elements in it. Now we can discuss different types of matrices. The first one is a row matrix. As the name suggests, a row matrix has only one row. Matrix 1, 2, 3 written as a row is an example. A row matrix is also called a row vector. Second type is a column matrix. As you guessed it, it is a matrix having only one column. A column matrix is also known as a column vector. Third type is a square matrix. As in a square, the length and breadth are equal. In a square matrix, number of rows and columns are equal. This is a 2 by 2 square matrix having 2 rows and columns. In a square matrix, if you join the first element at the top left corner and the last element at the bottom right corner using a line, the elements on this line are called the leading or principal or major diagonal elements. The other diagonal elements, that is from top right corner element to bottom left corner element, are called trailing or secondary or minor diagonal elements. Fourth type is a rectangular matrix, which has a different number of rows and columns. For example, these two matrices are rectangular matrices. The first one with order 2 by 3 and the second one having the order 3 by 2. Fifth type is zero or null matrix. For a null matrix, each element will be 0. That means it has only 0 as its elements. It can be of any order, as clear from these examples. Sixth type is a diagonal matrix. First of all, a diagonal matrix is a square matrix. Secondly, all the elements except those on the leading diagonal are 0. Remember, the elements on the leading diagonal may or may not be 0. Seventh type is a unit or identity matrix. It is a square matrix. All the leading diagonal elements are unity or 1 and all other elements are 0. Obviously, it is a diagonal matrix with leading diagonal elements equal to 1. Let us now discuss a new idea of transposition of matrices. Suppose A is a 2 by 3 matrix. Obviously, it has 2 rows and 3 columns. If we change these 2 rows into columns, we get a new matrix. This matrix is called the transpose of the original matrix A. It is denoted by AT or A dash. Note that changing rows into columns automatically changes columns into rows. Also note the change in the order of the matrices A and A transpose. In brief, the transpose of a matrix is the matrix obtained by interchanging its rows and columns. Next, we talk about the equality of matrices. When do we say two matrices are equal? For that, we need to check two conditions. The first condition is about the order of the two matrices. Two equal matrices will have same order. Second condition is about the elements. Equal matrices will have equal elements in their respective positions. For example, consider the two matrices A and B. Both have 3 rows and 2 columns. So they are of the same order, 3 by 2. Secondly, all the elements in the corresponding positions of both the matrices are equal. As they satisfy both the conditions, the matrices A and B are equal. Note that these two matrices are not equal even though all the non-zero entries are 1 for both the matrices. This is because they are not of the same order. Conversely, when two matrices are given as equal, then we can equate the corresponding elements of the matrices. Here, since the given matrices are equal, equating the first element, we get x equal to 1. Similarly, equating the second elements, we get y minus 2 equal to 2, which implies y is equal to 4. Can you find the values of x, y, a and b for this matrix equation? Try for yourself. The answer will be at the end of this video. Next, let us think how can we do arithmetic operations using matrices. How do we add two matrices? Suppose we have two 2 by 2 matrices. To add these matrices, we just add the corresponding elements in it. So here we add 1 and 2, minus 1 and 0, 3 and minus 5, and 2 and 1. So we get the resultant matrix as matrix 3, minus 1, minus 2, and 3. Now the question is, can we add any two matrices like this? Suppose we have two arbitrary matrices. Is it possible to add these two? The answer is no. Why? Looking at these matrices, we see that corresponding to the last row of the first matrix, there is no row in the second matrix to add. So the primary question is, what is the condition for two matrices to add? The answer is, they must be of the same order. This is same for subtraction. So in brief, any two matrices of the same order can be added or subtracted. Here are two matrices A and B. We need to find A minus B. So we do this between the corresponding elements of both the matrices. So the first element will be minus 2 minus minus 2. Second element is 1 minus 3, then 6 minus 4, minus 3 minus 5, 1 minus 0, and minus 4 minus minus 6. So the resultant matrix will be equal to matrix 0, minus 2, 2, minus 8, 1, 2. Given the matrix M with elements 5, minus 3, minus 2 and 4, find M transpose, and if possible, find M plus M transpose. Here it is stated as, if possible, find the sum. That means we need to check if M and M transpose are conformable for addition. We already know the condition for any two matrices to add is they are of the same order. So first we need to find M transpose and then check if M and M transpose are of the same order. Here M transpose is the matrix 5, minus 2, minus 3, 4. As M is a square matrix, the order does not change by transposition. Hence, both the matrices may be added. Now, adding the matrices, we have 5 plus 5, that is 10, minus 3 minus 2, that is minus 5, minus 2 minus 3 again, it's minus 5, and 4 plus 4, that is 8. So the result matrix is 10, minus 5, minus 5, 8. Now suppose A is the matrix 2, 4, 1, minus 3, 3, 2. The question is, can we find the sum of A and A transpose? Note that the order of A is 3 by 2. Now let's see what is A transpose. Now A transpose is 2, 1, 3, 4, minus 3, 2. Obviously, the order of A transpose is 2 by 3. Since both the matrices are of different orders, they are not conformable for addition. In brief, a matrix and its transpose may be added only if it is a square matrix. Additive identity. In the real number system, we have 0. If we add 0 to any real number, or conversely, the real number to 0, we get the same number. Hence, 0 is called the additive identity in the real number system. Coming back to the system of matrices, do we have such a matrix which when added to any matrix, we get the same matrix? Or in other words, is there any matrix X such that A plus X equal to A equal to X plus A? The answer is yes. We have the null matrix. For example, matrix 1, 2, 3, 4 plus the null matrix equal to matrix 1, 2, 3, 4, that is same as null matrix plus matrix 1, 2, 3, 4. Hence, the null or 0 matrix is called the additive identity in the system of matrices. Additive inverse. Suppose we add two matrices A and B and we get a null matrix as the result. In that case, we say that A is the additive inverse of B, and B is said to be the additive inverse of A. Let these matrices be A 1 minus 2 3 1 and B minus 1 2 minus 3 minus 1. Obviously, if we add these two, we get the null matrix. Thus, A and B are additive inverses of each other. In fact, we can observe that the matrix B is the negative of the matrix A and vice versa. Next, we see how to solve matrix equations. Suppose A and B are two matrices of the same order. Suppose there is an unknown matrix, say X, so that A plus X equal to B. Then this unknown matrix can be obtained by X equal to B minus A. For example, assume these matrices are A minus 1, 0, 2, minus 4 and B 3, minus 3, minus 2, 0. It is also given that A plus X equal to B. We need to find the unknown matrix X. So X can be found by X equal to B minus A. That is matrix 3 minus minus 1, minus 3 minus 0, minus 2 minus 2 and 0 minus minus 4, which is the matrix 4, minus 3, minus 4 and 4. Thus, we find the unknown matrix using the given equation.